Good evening, children.
Good evening, ma'am.
Good evening.
Good evening, children.
Good evening, ma'am.
Happy
evening.
Women's Day, ma'am.
I heard something.
Good evening, ma'am. Happy Women's Day, ma'am.
Happy Women's Day,
Thank
ma'am.
you. I think
Happy
I
Women's Day, ma'am.
heard from somebody earlier. Okay, thank you, children. Thank you.
I only said that time, ma'am. Arnav.
Arnav. Yes. Okay, thank you so much, Arnav. Thank you, children. Yeah, I think we discussed this in yesterday's class. Example 10. We are working this exercise from behind. So we finished the exercise, the questions in the exercise 13.3. Now the examples preceding the exercise. Example 10. A copper rod of diameter 1 centimeter. Copper is the material, rod, so cylindrical mostly, right? So a copper rod, copper is the material, rod, so cylindrical, of diameter 1 centimeter. So radius is 1/2 centimeters. And length, so height, 8 centimeters, is drawn into a wire. That means it's melted and recast into a wire. Drawn into a wire. Wire is a thin, long cylinder. It's a flexible cylinder. Wire, copper wire, what you find inside, the electrical stuff, electrical wires. When the electrician bites that, wire, that outside, what do you call that, insulator? He bites off that insulator. What you see inside is the copper wire. The wire which is used to connect, lights and tube lights, all electrical appliances. So there are copper wires running inside the insulator. Yes, so you know it better. So a copper rod of diameter. So for the cylinder, so for the copper rod, you know the radius, you know the height. That is drawn into a wire. Wire again is a cylinder. The copper rod is a cylinder. The wire is also a cylinder. The wire is a flexible cylinder because it can be rolled. You can roll it. You can roll it. You can wind it around something. So it's a flexible cylinder. So it's drawn into a wire. So it's a long one. Wire is a cylinder. It's a long cylinder. Wire of length 18 meters. 18 meters. Okay, length 18 meters or 1,800 centimeters of uniform thickness. Thickness is the diameter of the wire. Thickness is not the radius. See, how do you hold the wire? Imagine you're holding the wire between your thumb and forefinger. Imagine that. You are holding a wire. Now, right now you're using a gadget, right? So maybe you have connected you have put the gadget on charge. If it's a laptop and you put it on charge, you can see the wire beside. So hold the wire between your thumb and forefinger. That is the thickness of the wire, which is not the radius, which is the diameter. Get hold of a wire. Hold the wire between. How will you hold the wire? Don't put it inside your fist. Hold it between your thumb and forefinger. So what you're holding is the diameter. The thickness of the wire is the diameter of the wire, not the radius. So find the thickness of the wire, meaning find the diameter of the wire. Uniform diameter it has, uniform thickness. The cylinder. So find the thickness or the diameter of the wire. So what is the equation, children? Volume of the copper rod. Volume of the copper in the rod is equal to the volume of the copper in the wire. The volume is the same in both the cases. The volume of the material in the copper, the volume of the copper in the rod, in the cylindrical rod, is equal to the volume of the copper in the wire. So just equating the volumes. Both are cylinders. So you can differentiate their radius and height, saying R1, H1 and, RH. Show you the answer slide. So see here. Please listen. Copper rod is a cylinder of radius 0.5 centimeters because diameter is 1 centimeter. So radius 0.5 centimeters. Copper rod is a cylinder of radius 0.5 centimeters and height, length 8 centimeter. Length 8 centimeter. Wire is also a cylinder of height 18 meters or 1800 centimeters. And radius we don't know. We don't know the radius. See, whenever we have cylinders, we try to find out the radius and height, right? That's what we've mentioned here. We're trying to find the radius and height from the question. So this is what we have. We have to find the thickness of the wire. We have to find the thickness of the wire. That is the diameter of the wire. That's the diameter of the wire. So we have collected all the information given here like this. Now, volume of the wire is equal to volume of the rod. Volume of the wire is equal to volume of the rod. Wire is a cylinder, so pi r square h. So pi r1 square h1. Rod pi r square h. Because for the rod we've used r and h, so pi r square h. For the wire we've used r1 and h1, so pi r1 square h1. How do we simplify this? Pi on either side gets cancelled. R1 square we don't know. R1 we don't know. So R1 square. H1, see here, 1800. All the values must be in the same unit, children. Centimeter, centimeter, centimeter. So 1800. See here, it's here, 1800. Into, sorry, is equal to R square, 0.5 the whole square. Into H8. Work this to find the value of R1. Double it to find the thickness of the cylinder. Why double it? Because we have to find the diameter. We found the radius. We'll get the radius. Double it to find the diameter. Please go through the answer again. Read the question. Go through the answer and then write down. You can use 1 by 2, children. You please use 1 by 2 and calculate. One diameter is 1, radius is 1 by 2. You can also use 1 by 2. You can use 0.5. Not wrong. I think a fraction will be more comfortable. R is 1 by 2. That you have here. B part you have it there. Above you can see the working with 1/2. You can see the working with 1/2. Is it over, children?
Yes, ma'am.
All right. The copper rod becomes copper wire. So the volume of the copper in the rod is equal to the volume of the copper in the wire. Both are cylinders. So pi r square h only you will have on both the sides. But differentiate the radius and height. R1 H1 RH. Thickness of the wire means the diameter, because when you hold it, I told you between your thumb and forefinger, you're catching hold of the thickness of the wire. You're getting the thickness of the wire between your fingers. So it's a diameter. Diameter. So double the radius to get the diameter. You can leave it as 1/15 centimeters. You can leave it as 1/15 centimeters. All right. Example 9. Selvi's house has an overhead tank in the shape of a cylinder. Overhead tank in the shape of a cylinder. This is filled. The overhead tank is filled by pumping water from a sump. Sump is the underground tank. The water is filled in the sump, and then from there, by means of a motor, water is transferred from the sump to the overhead tank. So this is filled by, the overhead tank is filled by pumping water from a sump, pumped with the help of a motor from a sump, which is in the shape of a cuboid. So sump is a cuboid. The overhead tank is a cylinder. Okay. The sump has dimensions. Cuboidal tank dimensions are given you. Okay. The overhead tank has its radius 60 centimeters and height 95 centimeters. So for the cylindrical tank, we have cylindrical overhead tank, we know the radius and height. For the sump, the underground cuboidal tank, we have the dimensions LBH. Now what is the question then? Find the height of water left in the sump. We have all the values for the cylinder and cuboid, the sump and the overhead tank. Then what should we find? Find the height of the water left in the sump. Height of the water, not volume of water, height of the water left in the sump after the overhead tank has been completely filled with water from the sump which had been full. So the sump is full of water. The overhead tank is empty now. Overhead tank is empty. The sump is full of water. Water from the sump is pumped up to the overhead tank. Now the tank is full. Overhead tank is full. In the sump which was full is now not completely full of water. There is some water left in it. You should find the height of the water left in the sump. We'll read the second part of the question. Compare. We'll see that later. We'll answer the first question, the first part of the question. Sump full of water. Overhead tank empty. Water is pumped from the tank, from the sump. Sorry, water is pumped. Let me come again. The sump, which is in the basement, is full of water. The sump is full of water. Overhead tank is empty. Water from the sump is pumped up to the overhead tank. So after some time, the overhead tank is full of water. The cylindrical tank is full of water. Now there is, the sump has an inlet pipe. Water is not flowing into the sump. Okay. So it was full of water. Now because some water is pumped to the overhead tank, the water level in the sump has reduced. The water level in the sump has reduced. You should find the height of the water in the sump. That is, there is some water remaining in the sump. What is the height of the water is what you'll have to find. So to find the height of the water left in the sump, you should first find the volume of the water that is left in the sump. Okay, we'll find the height of the water. To find the height of the water left in the sump, you must find the volume of the water that is left in the sump. Remember that. Understand like that. To find the height of the water that is left in the sump, we need to find the volume of water that is left in the sump. So we'll write tank, overhead tank, and sump. We'll take all the values in centimeter. We'll take everything in centimeter because then we can get rid of the decimal point. So overhead tank, what is the radius? Overhead tank radius 60 centimeters. Height is 95 centimeter. Um, 1.57 into 100, 157 centimeter, 144 centimeter, 95 centimeter. So tell me, how will you find the volume of water left in the sump? You have to find the height of the water in the sump. What was the height of the water originally in the sump when it was full? When the sump was full of water, what was the height of the water?
$95 centimeter.
95 centimeters. When the sump was full of water, the height of the water in the sump is the height of the sump. The height of the water in the sump is the height of the sump. 95 centimeters. Because when it's full of water, the dimensions of the cuboidal water there will be equal to the volume of the dimensions of the sump. The length of the water is 157 centimeters. The breadth of the water is 144 centimeters. The height of the water is 95 centimeters. Okay, so how do we find the water? How do we find the water left in the sump, children? What will you do? How do you find the volume of the water left in the sump? Find the volume of sump. That's the first step. Find the volume of the sump or volume of water in the sump. Volume of water in the sump. That's the first step. LBH. Then find the volume of water in the overhead tank. In the overhead tank. overhead tank and subtract these two, because this is the volume of water in the sump and this much is removed. Volume of whatever is the volume of the overhead tank, that volume is removed. That volume is pumped up. Whatever is the volume of the overhead tank, that volume of water is now not there in the sump, because from the sump it's transferred to the overhead tank. So this difference will be the volume of water remaining in the sump. Volume of water remaining in the sump. Should find the volume of the water in the sump. You should find the volume of the water in the overhead tank. Subtract. You will get the volume of the water left in the sump. So you get the volume of water left in the sump, right? So some answer, let me see the answer. 1073880. 1073880 centimeter cube. So this is the volume of the water left in the sump. How do you find the volume of the water left in the sump? Length of the water into breadth of the water into height of the water is equal to the volume of the water left in the sump. Length of the water into breadth of the water into height of the water is the volume of the water left in the sump. What will be the length of the water? Will be the length of the sump, 157. What's the breadth of the water? Breadth of the sump. Height of the water, now the height has fallen. So that new height you should find is equal to 1073880. Working this, you will get the height of the water left in the sump. And then we'll have to compare the capacity of the tank to that of the sump. That will be easy because we already found the capacity of the sump here and we found the capacity of the tank. We should just divide these two answers. We should just divide these two answers to get the ratio. Here compare the capacity of the tank with that of the sump. And important, use pi as 3.14. We are going to convert everything to centimeter. Everything to centimeter. Please go through the answer first, children. First, give it a reading. And then if you're convinced you have understood, start writing. Instead of writing this, you can even say you can just write it like I told you, length of water into breadth of water into height of water. Volume of the water in the sump will be length of water into breadth of water into height of water is equal to that value. Length of the water will be 157, breadth will be 144. Into height we don't know. Any questions, children?
No, ma'am.
Take some more time, go through the answer. Write down the answer. then here you even say capacity of the tank, capacity of the sump. Capacity is the entire, when it's completely filled with water, the maximum volume it can hold is the capacity. Like in the case of now this container, supposing the height is 14 centimeters and the radius is 7 centimeters, and some liquid is filled to a height of 7 centimeters. So when you're asked to find the capacity of the container is the capacity meaning the volume if it is full of liquid. The capacity is the amount of liquid the container can hold. So okay, when you're asked to find the capacity of the container, you should find pi r square h with these values, pi r square, and h you must take 14. That's the capacity. Liquid is not filled to that height, but what is the capacity of the container? Is the total, the amount of liquid it can hold. So it can hold up to a height of 14 centimeters. So you should take height as 14 to find the capacity. But the volume of the liquid, in the container, the volume of the liquid in the container is pi r square into h, which is 7. When you take the height as 7, it's the volume of the liquid in the container. If you take the height as 14, you're finding the capacity of the container. There is no liquid. Liquid is only to the height of 7 centimeters, not 14. But when you take height as 14, you're finding the capacity. In that sense, you can write capacity of the tank. That is the full volume of the tank. Capacity of the sump. You can make those changes which I've made now instead of volume. Finish writing, children?
Yes, ma'am.
Yes. Okay. What about the others? Please respond. Should I wait? Class, use the emoji, raise your hand. Shivani, Tirunesh, Priya, Shruti, Shabaligrish, Arnav, Lakshita, Muttuvek, Sudarshan, Shriya, and Nishita. Very good. Now, children, please tell me, have you finished writing? Make some noise. Have you
Yes,
finished writing? Okay. Solve. Physical classes, we have to tell you to keep quiet. Online classes, we have to ask you to make noise. What an irony. Is it understood, children? Any questions here?
No, ma'am.
Okay, Tirunesh. Fine. Yeah, this is easy. Okay. This will come to the end of this exercise also. Yeah, please help yourself with this one. Complete this. This one will be followed by a test. So with this, we have finished volumes and surface area. Surface areas from the textbook. Three gets cancelled, pi gets cancelled. 4 into r cube. R1, that is the radius of the cone. Radius of cone, 6 centimeters, so 6 square. Into height of cone, 24. So the radius of the sphere is 6 centimeters. Is it over, children? Finish writing?
Yes, ma'am.
Okay. So a cone becomes a sphere. The amount of clay in the cone will be equal to the amount of clay in the sphere. So their volumes are equal. Equating the volume, substituting the given values, find R. This is removed from your syllabus. Also not there. Yeah. Try this question. A rectangular tank is 225 meters by 162 meters at the base. With what speed must water flow into it through an opening 60 centimeters by 45 centimeters so that the level may be raised by 20 centimeters in 5 hours? Write down the question. Give the heading extra problems from surface areas and volumes. Write down the question first. Just think about this, give it a shot. I'll show you one more question. This, children, write this. I'll put you with another question also. Yeah. Or no, let me not. We'll do this, children. We'll work this and then go to the next one. I'll just give you some time. Please think about it. All right. Now try to answer these questions. If I say that the volume of water that flows out of the opening in 5 hours is equal to the volume of water. See, I believe in writing an equation in words. Read the question and try to construct a meaningful equation in words so that they can be converted to the respective formulae, and then you can substitute the values and work to find the unknown. Volume of water filled in the rectangular tank in 5 hours. See, there is a rectangular tank and through an opening, water is being filled into the rectangular tank. It's given 60 centimeters by 40. The opening is also cuboidal. The opening is cuboidal because it's given 60 centimeters by 45 centimeters. So that means 60 centimeters by 45 centimeters, meaning the dimensions like LBH, 2 of it is given to us. So the opening is also cuboidal. The opening is cuboidal. The mouth is rectangular. The mouth is rectangular and the water is flowing like this. The water flows and comes out through a rectangular opening. The rectangular opening has these dimensions, 60 centimeter by 45 centimeter. The water, see there's a tank and water flows into the tank. Water flows into the tank. It comes out through a rectangular opening. The dimensions of the opening given to you here, 60 centimeters by 45 centimeters. The water flows into the tank. How long does the water come out through the opening? For 5 hours. So that means for 5 hours the tank is getting filled. So the volume of the water that flows out of the opening in 5 hours, the volume of water that flows out of the opening in 5 hours is equal to the volume of the water filled in the tank in 5 hours. The mouth of the opening is rectangular. The mouth of the opening is rectangular. There cannot be just one rectangular opening like that, you know. So the pipe, maybe it's a pipe, is cuboidal. The pipe is cuboidal. The mouth is rectangular. The opening is rectangular. It's a cuboidal pipe then. See, I'm pausing for you to think. Is the equation correct? If the equation is correct, then it's easy for me to go further. The volume of the water. So there are two things here. An opening through which water is flowing out. An opening through which water is flowing out. The opening is rectangular. Length and breadth given 60 centimeters by 45 centimeters. The opening through which the water is flowing is rectangular. So that means that pipe is cuboidal. The height, H is missing. Not the height of the pipe, the height of the water column is what we're going to find. That's about the opening. Then there is another one, which is the rectangular tank. Rectangular tank's length and breadth is given. And the required level of water is given 20 centimeters. The desired level of water in the tank is 20 centimeters. The rectangular tank has length and breadth 225 meters and 162 meters respectively. What height of water you want in the tank? 20 centimeters. In how many hours? In 5 hours, you want 20 centimeters of water to be filled in the tank. Then what should be the speed of water is the question. If you want the tank to be filled with water to a height of 20 centimeters in 5 hours, see your conditions. You want the water to be filled to a height of 20 centimeters in 5 hours exactly. Not less, not more. Then what should be the speed of the water that comes out the pipe is the question. Pipe meaning that opening. The opening's length and breadth given. Rectangular. The rectangular tank's length and breadth given. That will not change. The height of the water in the tank can change. Can be different. But the length and the breadth has to be fixed for the tank. So that is given to you. The length of the tank, the breadth of the tank is given to you. What is the desired level of water in the tank? 20 centimeters. What's your other condition? It should be filled in 5 hours. For these conditions, what should be the speed of the water? That is, should it flow at 5 kilometers per hour or 10 kilometers per hour, 20 kilometers per hour? What should be the speed of the water that is coming out of the opening so that 20 centimeters, this height of water is filled in the tank in 5 hours. So this is the equation, children. Volume of water that flows out of the opening in 5 hours is equal to the volume of the water that is filled in the rectangular tank in 5 hours. So the volume of the water will be rectangular. The volume of the water is LBH is equal to this is also LBH. What's the length? 60. What's the breadth? 45. What's the, so what should be that height of the water column? What should be the height? So in 5 hours, what should be the height of the water column? That is what we're finding. It's not the height of the pipe. The pipe, that cuboidal pipe might be a very small piece. We are trying to find the height of the water column that has been discharged in 5 hours. So that height this is. Height is equal to length of the rectangular tank, 225 meters, so 20 centimeter. Breadth 16200 centimeters into height 20 centimeters. Please work this and tell me H for me. Please work and tell me the value of H. You may write this. Whatever you see on the screen, you can write it down. Finished writing, children? Please tell me the value of H. I already found it using the calculator. Children, what's the value of H?
I'm doing, ma'am.
Yeah.
Ma'am, is it 2,70,000?
2,70,000, huh?
Yes, ma'am.
How many zeros you have?
Ma'am, 27 lakhs.
Yeah, 27 lakhs.
Oh,
No, it's not 27 lakhs also. It's more than that. Oh, no. Somebody, I think Thirunesh, you're right. No, I just mistook the zeros. Yeah, it's 27 lakhs. 27 followed by 5 zeros. 27 lakhs. Yes, so H is equal to 27 followed by 5 zeros or 27 lakhs. Centimeter. So this is really big to convert. Even if you convert it to meters, you can still be able to convert it to kilometers. So let's convert this to kilometers. So this H is equal to 27, 1, 2, 3, 1, 2. See, when you divide by 100, you have converted it to meters. When you further divide by 1000, you are converting it to kilometers. First, when you divide by 100, what you will get? You will get it in meters. Then when you further divide that meter by 1000, you will get it in kilometers. This is conversion, children. Centimeter divide by 100, it will be converted to meters. Further divide by 1000 to convert it to kilometers. So I think this is 27 kilometers. H is equal to 27 kilometers. So we got it. So the height of the water column in 5 hours, if you make that water column stand, it'll be 27 kilometers. Length 60 centimeters, breadth 45 centimeters, height 27 kilometers. That much of water has come out in 5 hours. This height of water has come out of the pipe in 5 hours. So this height has come out in 5 hours. We want the speed. That means we want per hour. See, you're saying that I can go 10 kilometers in, okay, we said 12 kilometers. Okay. So you're saying I can go 12 kilometers in 3 hours. So that means what is your speed? 12 by 3, 4 kilometers per hour. 4 kilometers per hour. So on your cycle, you're saying you can go 12 kilometers in 3 hours. Just saying, for example, 12 kilometers in 3 hours. So that means what is your speed? 12 by 3, 4 kilometers per hour. Distance by time. Distance 12 kilometers by time 3 hours. 12 by 3, 4 kilometers per hour. So here the distance is nothing but 27 kilometers. The height of the water that comes out in 5 hours is 27 kilometers. See, you just imagine something like this. The opening, okay, the opening is 60 centimeters by 45 centimeters. Imagine a cuboidal vessel. A cuboidal vessel, 60 centimeters long. Excuse me. 45 centimeters wide and of height 27 kilometers. That, whatever is the capacity of that vessel, that is the volume of water that has come out in 5 hours. The height of the water column that's thrown out of the pipe in 5 hours is 27 kilometers. So 27 kilometers has come out in 5 hours. In 1 hour, 27 by 5. Whatever is 27 by 5. 27 by 5. 5 5s are 25. So 5.4 kilometers per hour. So the water should flow out of the opening at a speed of 5.4 kilometers per hour. Then the conditions will be satisfied. Yeah, I have the answers here. So you can see the steps here, children. Ignore this one. See the third answer, the third one. Volume of water that flows out of the aperture in 5 hours is equal to volume of water filled in the rectangular tank in 5 hours. If you can write this in words, it will be easy. The volume of the water that flows out is equal to the volume of the water that is filled. That's all. Next, after this, so the height of the water column, you can continue. Height of the water column in 5 hours is 27 kilometers. That height or that length of water has been thrown out of the aperture in 5 hours. So height of water column formed in 1 hour. 5 hours, 27 kilometers. 1 hour, 27 by 5. 5.4 kilometers. So you can put them together. So 5.4 kilometers per hour. If this is comfortable for you. Or you can say speed of the water flowing. You can see it below. You can work it like that. Or speed of the water flowing out of the aperture is equal to distance by time. Speed is distance by time. So 27 kilometers by 5 hours. 5.4 kilometers per hour. See, if you say, I can cycle 10 kilometers in 1 hour, that is your speed. 10 kilometers per hour is your speed. If you say, I can cycle 10 kilometers in 1 hour, then what is your speed? 10 kilometers per hour. So the height of the water column formed in 1 hour is 5.4 kilometers. So that means the speed is 5.4 kilometers per hour. Work whichever is comfortable for you, children. Use the formula or what I've done earlier. Completed, children?
Completed, ma'am.
Okay.
Ma'am, can you show the previous slide again?
Yeah, sure.
Thank you.
Yeah. Finish, children?
Yes, ma'am.
Okay. Thank you. Yeah, this is the next. A cylinder is within a cube. A cylinder is within a cube. Oh, I forgot to put the picture. difficult for me to draw. A cylinder is within a cube, touching all the vertical. No, we'll do this in the next class, children. Because without the figure, I don't know how I can explain. And it's difficult for me to draw it. What do I do? Cylinder is within a cube, touching all the vertical faces. A cone is inside the cylinder. If their heights are the same, with the same base, find the ratio of their volumes. Oh, I'm sure I won't be successful in drawing it. I'll just give it a shot. I can't draw a cylinder now inside this. So the cylinder knows like this. See here, this is the height of the cylinder. This will be the cylinder is such that it touches all the sides of the cube, all the vertical sides of the cube. So it will be like this, the cylinder. Okay, somewhat I've drawn. This is the cylinder. The cylinder touches all the sides. See here, touches all the vertical faces. It touches all the 4 vertical faces, standing faces, curved surface area. And then inside this, there is a cylinder. I'm sorry, a cone. Inside this, there's a cone. See, like this. There's a cone inside this. So outermost thing is the cube. Inside that cylinder, inside that cone. The outermost thing is the cube. Inside that cylinder and inside that cone. All their heights are the same. Height of the cube, height of the cylinder, height of the cone, all the same. And they have the same base. Which one will have the same base? Cylinder and cone. They have the same base, meaning they have the same radius. The cylinder and cone have the same base, meaning they have the same circular base. So same radius they have. Obviously, the base of the cube will be bigger than the base. See, circle is different from a square. They have the same base. The circular base of the cone and the base of the cylinder. So they have the same radius. Now, given this info, you should find the ratio of their volumes. Find the ratio of their volumes. I think I've managed to draw the diagram. You can understand. So let's proceed with this. Now tell me cube, cylinder, cone. Don't write down anything, children. I'll show you the answer. Like I showed you for the earlier one, I'll show you the answer. Don't write anything. Just discuss this first. Now let the edge of the cube, that's the outermost thing. Okay, so let's assume that let the edge of the cube be A units. Let the edge of the cube be A units. So for the cube, edge is A. For the cylinder, you need radius and height. And the cone also will have the same radius and same height because it's given. It's given. That's what is given. Heights of the cone and cylinder, same. Height of the cube, cylinder, cone, all the 3 same. Radius also same. Now tell me what will be the radius of the cylinder?
A by 2.
What is the diameter of the cylinder?
A.
Yeah, because the circle will touch all the sides like this. And the edge of the cube is A units. That means the diameter of the circle is A, which means the radius will be A by 2. Radius will be A by 2. The radius of the cylinder is A by 2 because the edge is A. See, from here to here, this one is A. So the diameter is A, which means the radius is A by 2. Okay, radius is A by 2. What is the height of the cylinder? What is the height of the cube?
A.
Height of the cube is A because cube length, breadth, height all are the same, A units. Height of the cube is A. So the height of the cylinder is A and the height of the cone is also A. What was the radius of the cone? A by 2. Diameter is A, radius A by 2 for both cylinder and cone. Height of the cube equal to height of cylinder equal to height of cone. A. Just a minute, children. Yeah, children. So we need to find the ratio of their volume. So volume of cube is to volume of cylinder is to volume of cone. Cube is A cubed. Please, let's do it together. So volume of cube A cube, cylinder pi r square h, and cone 1/3 pi r square h. Same r and same h, not r1 h1 and all that, because they have the same radius and height. The cone and cylinder. So now we are going to write r and h in terms of A. See here, we have r and h in terms of A. R and h in terms of A. We are going to substitute that. A cube is to pi. So since you see, supposing this volume of cube also had pi, you can cancel pi everywhere. But now you cannot cancel pi. So you take the value 22/7. See, if all the three had pi, you can cancel pi everywhere. But no, A cube does not have pi in it. So take the value 22/7 into r square. R square is what? A by 2 the whole square. A square by 4. A square by 4. R square. A square by 4 into h. A is to 1/3 into 22/7 into r square. A by 2 the whole square. A square by 4 into h, which is A. So now A cubed is to can something get cancelled here? Yeah, so this will become 11 and 2 children. So what is this? 11a cubed divided by 14 is 2. 11 and 2 here. So it will be 11 by 7 6 are 42. 42. The numerator a square into a is a cubed. Now you can see that all the three expressions have a cubed in them. So you can divide by a cubed throughout. Like a cube gets cancelled everywhere. A cube gets cancelled everywhere. So the ratio is 1 is 2. 11 by 14 is 2. 11 by 42. If you want to get rid of the denominators and have the proper ratio, you need to multiply by their LCM. You should multiply by the the LCM of the denominators, which is 42. LCM of the denominators is 42. So 1 into 42 is to 11 by 14 into 42 is to 11 by 42 into 42. See, this is the ratio, children. This is the ratio. But we don't understand what it means. So let's multiply every term by the LCM, 42. The LCM of the denominators, which is 42. 1 into 42, 11 by 14 into 42, 11 by 42 into 42. So this gives us the ratio, a proper ratio. 42 is to 14 ones are, 14 threes are. So 33 is to 11. Yeah, sorry. 11. 42 and 42 cancel, so 11. So the ratio, the required ratio is, or the ratio of their volumes is 42 is to 33 is to 11. It is simple. Answer now. Yes, children. Please write down. You can see it below. Same thing, what we just understood. Done, children? Is it over, children? Finish writing?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. That's all we can do from this because the remaining we don't have. This is about frustum, this is also frustum. I think this question I gave you once, right? Have we done this in the class, children? One minute. Yeah, let's do this one because water-based sums are very important. Yeah, let's do this. Don't have much time left for today's class. I think we'll try this one in today's class. 150 spherical marbles, each of diameter 1.4 centimeters, are dropped in a cylindrical vessel of diameter 7 centimeter containing some water, which are completely immersed in water. Find the rise in the level of water in the vessel. So what will be the, see now when marbles are dropped into the cylindrical vessel containing some water, it's given that the marbles are immersed in the water, so nothing overflows. It's not given that water overflows, so nothing overflows. The marbles are completely immersed in water. Now there will be an increase in the height of the water in the cylinder. When the marbles are dropped in the cylinder, the height of the water in the cylinder will increase. The height of the water, supposing it was originally some 10 centimeters, now it may become 18 centimeters. The volume of the water will increase. Sorry, the height of the water. The height of the water in the cylinder will increase. So that increase in height, why does it happen? Because the marbles have taken some space inside the cylinder. So the equation involves is volume of all the spherical marbles is equal to the increase in the volume of the water actually does not increase, but the height increases, right? That increase in height and the volume of the water pertaining to that height is equal to the volume of all the 150 marbles. I'll show you diagrammatically. So there's water like this. Same vessel, okay? Same vessel. water level increases. Okay. So now this was the actual height of the water. This is the actual height of the water. Now here you see that this is the increase in height. So this volume of water, let me draw it more clearly, children. Sorry. Take a bigger vessel. I'll take a bigger vessel. All right. So original height of the water. This is the original height of the water in the vessel. So like this is the original height of the water in the vessel. Now, how does this increase in the level of the water happen in the vessel? Because some some marbles have taken some space inside the cylinder. So I'm saying that this volume of water is equal to the volume of all the spherical marbles. This volume of, because why has it increased? Because the marbles have taken some space inside the cylinder. So the volume of this amount of water, this volume of water is equal to the volume of all the 150 spherical marbles. Is it correct? That change has happened, no? That change is because of the marbles. So the volume of the marbles is equal to the volume of that change. Is it correct, children?
Yes, yes.
Okay, let me show you the answer. Yeah. That's it. Then you just have to write the formula. Yes, please write down. Marble is a sphere, so 4 by 3 pi r cubed. Cylinder pi r square h. Volume of any part of water in the cylinder will be pi r square h. Is it over, children?
Yes.
Are we still writing? Done? Okay.
Completed.
All right. Yes, children, take a screenshot of this paper. You can try the first one. 2 is what we just did. 3, 2, yeah, 5, 6, all this is in your syllabus. This one I have to explain. You can just have a look at the answers. We'll discuss 3, children. 3, 4, 3, 4 and 7 we will discuss in the next class. And the homework which I gave you yesterday. The homework which I gave you yesterday and these 3 sums we will discuss in the next class. Take a screenshot. Done. Questions. These are the questions. Yes. Take a picture. All right, children. So we have only 10 at the end of the class. All right, children. So that's it for today's session. Lower your hands, Muthuver and Tirunesh. Yeah, now class, use the emoji. Raise your hand quickly. Sudarshan. All of you, very good. Sudarshan, Shivani, Nishita, Shruti, Lakshita, Arnav, Tirunesh, Muthuver, Shriyan, Priya. Very good, children. Thank you so much. All right, children. So that's it for today's session. Thank you. Good night.
Thank you.
Thank you.
Yes, happy Women's Day to all the young ladies in the classroom. Too late.
Thank you, ma'am.
Yeah. Good night.
Thank you, ma'am.
Good.